Hi, everybody. We're going to continue with proportions in this section and actually look at some applications here. So by applications, I just made some real world examples. And proportions are actually extremely helpful with a ton of real world examples. So I'm just going to show you a few in this video, but do note that they really have applications in so many fields, and they make comparing different quantities or changing from one value to another also very, very easy. So let's do a few examples. And the first example I'm going to use has to do with a map and has to do with scaling. So this is a great application if obviously you are reading a map. Now I know many of us just use our phone nowadays for our GPS, but if you're reading a map, it is drawn to scale. Or if you're going into any sort of design, right, then you may need to scale things down. So if you're looking at interior design, you're thinking about, where can I fit different furniture and you want to actually draw it out first, you're going to be drawing to scale. So it's important to be able to go from maybe an inch on a paper to a foot in real life, for instance. So this first example is about scaling. So let's say that 5 miles on a map corresponds to 2 inches. If city A and city B are 62 miles apart, how many inches is this on the map? Now, with proportions, there's actually a few different ways that you can set up proportions. So they're pretty forgiving in the setup, but I'm going to show you one way that I think is the easiest. And that's really with matching units. So think about here. I know that 5 miles corresponds to 2 inches, right? So that information goes together. It's connected. So I'm going to set that up as my first ratio here, or rate. So 5 miles compares to 2 inches. So that is my first rate, right? That information is connected together. And what I know from my other piece is that city A and B are 62 miles apart, and I need to know how many inches. So here's my question, right? I don't know the inches here. So my goal is to find the number of inches this correlates to on the map. So I'm kind of going back to my techniques here for how to set up a word problem, right? So think about my goal, and my unknown, what I'm trying to find is going to be my variable. So the inches is the X here. And you want to match up your units. So if miles was on top for my first ratio, then miles will be on top for my second ratio. So I'm going to put 62 miles. And then I don't know the inches, so I'm going to put X inches. So notice that I have miles to miles, inches to inches. And that each of my ratios represents one thing, right? That 5 to 2 represents the first piece of information, and then the 62 to X represents the second piece of information. So now I can go in and I can solve this. And I'm going to use my cross multiplication here. I think it's just a little bit easier. So I have 5 times X, and then 2 times 62. I'm not going to worry about my units as I do my multiplication. So I have 5x, and then 62 times 2 is going to be 124. And then I can divide both sides by 5. Now, 124 divided by 5, that's great, but it's kind of hard to understand what that means. So maybe I'm going to take out my calculator here and just see what that becomes. So when I take out my calculator, I do get 24.8, which I think makes a little bit more sense here. So I'm just going to use the decimal answer, but you can also use the fraction answer. I'll do that in a second. So here I just use my calculator. And remember that the X we were trying to find is about inches. So the answer would be that the cities would be 24.8 inches apart on the map. Now, again, let's say you don't want the decimal, you want a more specific answer here, like a fraction answer. Then what you can do here is just change this to a mixed number. And a mixed number will be fine as a final answer in this case, because again, now we're getting a solution. We're not just leaving it in ratio form. If we have ratio form, we don't really like to have mixed numbers in the ratio form, but it's fine for a final answer. So 5 goes into 12, 2 times, which is 10. And then 5 goes into 24, 4 times, which is 20. And I have a remainder of 4 here. So it becomes 24 and then 4/5 inches. So we could also leave it as a fraction. All right, let's do another example. Actually, I'm gonna go to a clean page too, so I have more room. So another great application here of proportions is actually medicine. And if anyone's going into a nursing program, then you're probably going to be doing a lot of work with proportions at some point with dosages and things like that. So there's a ton of applications here with dosages and different medicines and things. So let's say a standard dose of an antibiotic is 4 cc's, so cubic centimeters, for every 25 pounds of body weight. What is the dose for an adult that weighs 160 pounds? All right, so start with what we know first. So a standard dose of antibiotic is 4 cc's for every 25 pounds, right? That information is connected together. So I'm going to do 4 cc's for 25 pounds. What is the dose for an adult that weighs 160 pounds? Okay, so our goal here is to find the dose. Now think about this, your dose was the cc's, right? That was my units. So that's going to be your X. So I don't know my dose, but I do know the weight for this person is 160 pounds. So again, notice units match on top, units match on bottom, and then this is one kind of person, this is another person, right? This is the standard dose, this is the actual person. And again, there's more than one way to set up a proportion. So if you have another technique you've already learned or that you're good at, then that's totally fine too. I'm showing you what I think is the easiest way to do it. All right, and now we're going to go ahead and solve. So I'm going to multiply this way and then this way. So I have 4 times 160, 25 times X. So I have 640 equals 25x. I do need to solve this by dividing both sides by 25. And I'm going to be a little lazy and use my calculator here. So 640 divided by 25 gives me 25.6. Okay, so a 160-pound person would receive 25.6 cc's of the antibiotic. And CCs actually is a unit in with nursing. There's other units as well. So often we do weights with nursing, not in pounds, but in kilograms. So you may notice that's a little bit different. This problem is kind of just made a little bit more general. Sometimes we'll also do dosages in milliliters. So if you're, drinking the medicine that way, often with children's medicine and things like that, it may be a different unit there too. But this is just a nice application. And a lot of times medicine really is administered by weight, not so much by age or anything, but by weight tends to be the overall kind of example there that we use. All right, let's do another one. All right, I'm going to do another example, and this one I'm going to do with baking. So here's, again, another application that I think a lot of us can relate to when we're baking. So I know sometimes when I'm cooking, I may want to double a recipe or triple a recipe or something like that. Or maybe I want to actually use like 1.5 times a recipe. I know that sounds kind of crazy, but sometimes, let's say if I'm making pancakes, one standard recipe is too small, but 2 is way too many. And sometimes if I put them in the fridge or freeze them, nobody eats them. So I kind of just want to make what's just right. So I may want to make 1.5 times that recipe or something like that. So here I figured let's do a baking example to kind of learn a little bit how to convert over. Okay, so the example I'm going to do is on chocolate chip cookies, and I'm just going to make this up, so it's not an exact recipe, but you kind of can use the same idea. So let's say I want to make some chocolate chip cookies. So I know that one bag of chocolate chips contains, let's say, about 500 chips and can make 24 or 2 dozen. So maybe Professor Paula needs to make 100 cookies for a school bake sale instead. So I'm going to ask the question, how many bags of chips must she buy? So Professor Paula is making chocolate chip cookies. One bag of chocolate chips contains about 500 chips and can make 24 cookies. Professor Paula needs 100 cookies for a children's school bake sale. How many bags of chocolate chips must she buy? So let's look at my question. How many bags of chips must she buy? So my goal is to figure out, find the number of bags, right? That's what I want to do. How many bags? So that's going to be my X. So let's see what I notice here. I notice that I have information about, let's use a different color. One bag of chocolate chips contains 500 chips and can make 24 cookies. And then for my other information, I know that I need 100 cookies, and my goal is to find the number of bags. So this problem's a little bit trickier, and that's because I have this extra piece of information about 500 chips. Now look at my goal. My goal is about how many bags I have to buy, not how many chips I need. So that information about 500 chips is actually just extra information that really is irrelevant to the problem. I mean, it sounds delicious, right? But I don't really need it for the math. So if I think about what I'm looking for, my question is all about the number of bags, and I need 100 cookies. So I'm looking at bags and cookies here. And for my first ratio, I have bags and cookies as well. So this chip information is irrelevant in this particular problem. If I ask the question, how many chips do I need, then that's different. But I don't care about the chips, I just care about the number of bags. So for the basic information, I see that one bag yields me 24 cookies. And I need to know how many bags to buy to get 100. So this is what I'm trying to solve here. So sometimes we have to be a little bit careful. Think about what we know, what we're looking for, because it's always a ratio to ratio. So you have two things to two things, not three. So this chips idea is just extra information that I just don't need for this problem. Notice I have bags to bags, cookies to cookies, and I'm ready to start. So I'm going to multiply across here. So I have one bag times 100 cookies equals X bags times 24 cookies. So I have 100 equals 24x. I'm going to go ahead and divide here. And I know it's going to be a little bit over 4 because I know 100 divided by 25 is 4. So I'm going to divide this out. So I get that x is about 4.1666, and that 666 does keep repeating. So it's going to keep going on and on and on. So we need about let's round here, 2 decimal places, 17 bags of chocolate chips. So think about this. If I go to the grocery store, I can't just buy 4.17 bags of chips. So Professor Pollard will need 5 bags in this case, right? Now I know I don't need the full 5 bags, right? That doesn't necessarily, I'm gonna have extras, so I have a lot left over. But if I wanna make at least 100 cookies and I want my cookies to be awesome, I don't wanna skimp on the chocolate chips here and just only buy 4 bags, I'm gonna buy that extra bag of chips, and then I'll have a little bit extra for next time.